Okay, so we're finishing off with deletions and microdeletions. Deletions of areas of chromosomes can also occur. These deletions can be large and visible, can be seen with a microscope, or very small, so small that you can't even see under the microscope. These are called microdeletions. Deletions tend to occur due to unbalanced crossing over or unbalanced translocation during meiosis. If there's an exchange of genetic material, the cell can get confused where there are lots of repetitive regions. So if there's an exchange of genetic material, the cell can get confused where there are lots of repetitive regions. This results in bits missing in one chromosome and a duplicated amount in the other. So here we see deletion due to unbalanced translocation. So deletions occur due to unbalanced translocation. As we said here, this is an unbalanced translocation which is part of the chromosomal rearrangement. So an unbalanced translocation can lead to deletions and duplications. Easy peasy lemon squeezy. So, as we can see in the picture, on the left is our normal balanced translocation, where the chromosomes exchange at the same height and the same genetic information is exchanged. So equal genetic information is exchanged. Yes, there's an equal exchange of genetic material, or there's an equal exchange of genetic material. Simple. However, in unbalanced translocation, there's an unequal exchange of genetic material. And as we can see here on the right, here's an unbalanced translocation. The chromosomes exchange at different heights. Therefore, you get a duplication in one chromosome and deletion in the other. So an example of this is 22q11 deletion. This is quite a common deletion. Such children have specific facial features. An affected person can be identified by the FISH method, where we see that on the slide the probe is not showing normal fluorescence. It should show 4 fluorescence on each chromosome, but on one there's only 2. So I'm going to try and get a picture of that up for you now. So 22q11, and here we can see it on slide 44. So as you can see on the chromosome on the right, there are 4 probes, whereas the chromosome on the left, there's only 2 probes. So it should show 4 fluorescent probes on each chromosome, but on one there's only 2. Children with this have lots of problems, including cardiac problems, renal problems, learning difficulties, hypocalcemia. In summary, chromosome aneuploids are most common chromosomal abnormalities. Cross-structural abnormalities are caused by breakage and incorrect repair. Changes to chromosome may be balanced or unbalanced. Carriers of balance changes may be at risk of having children with abnormal phenotypes. Microdeletions and duplications are caused by unequal crossing over or unequal translocations, which can have significant clinical consequences. Thank you for joining me. Jazak. Peace out.